Reactathon 2022. We are here for the pre-conference day of remote talks. I'm Anjana Vakil, coming at you from San Francisco. I'm a senior developer advocate at Hasura, and really excited to be kicking off Reactathon with y'all at this special day of virtual talks. So this is going to be a extra special day of talks before the in-person conference, and so that we can all chat and connect as a great community of front-end and full-stack devs all over the world. Make sure that if you haven't already, you hop into the Discord. You can find the link in the footer at reactathon.com. So as I'm sure you've gathered by now, Reactathon is finally returning in person this May. So over 3 days, May 3rd, 4th, and 5th, we're going to be gathering at the beautiful Cal Shakes Amphitheater in Northern California. And to make sure everyone is safe, we are going to have the entire event taking place outdoors. Everyone will be fully vaxxed and everyone will be tested for admission. Now, Reactathon is known for having a pretty incredible lineup of speakers, and this year is particularly special because not only do we have some amazing speakers well known in the React community, folks like Kent C. Dodds, Lydia Halley, David Khurshid, Jen Creighton, Shruti Kapoor, Ryan Florence, Lee Robinson, so many awesome speakers. We also have a full day of talks dedicated to serverless and edge computing and infrastructure as code. So speakers at that event, which is called Serverless in the Park, are going to include Matt Billman from Netlify, Jeremy Daly of Serverless, Farrah Campbell from AWS, and a bunch more awesome speakers. So you can learn more about that day of talks at serverlessinthepark.com. Now, I might be biased, but I also think this year's list of sponsors is pretty incredible. We have as presenting sponsor this year, Vercel. So Vercel is a front-end cloud platform that facilitates a really fast and really enjoyable, I think, development and also deployment experience. So they make it easy to integrate any framework or backend, and they also provide the global edge infrastructure to help you deliver incredible web experiences with performance as the default. And they're going to have many of their awesome team members at the sponsor booth at the event, so make sure to say hi. Now, Hasura, the company I recently joined, is also a platinum sponsor this year. And we're really excited because Hasura has sponsored Reactathon from the very beginning and always enjoying the energy and the community and the connections from this event. So if you're not familiar with Hasura, we provide instant GraphQL APIs on top of your data. So whether it's new or existing applications, Hasura lets you connect to your databases and other APIs, whether they're REST or GraphQL, and basically sets you up with an instant, real-time, unified GraphQL API that, again, might be biased, but I think it's a pretty great development experience too. So check it out, hasura.io. It's an open source engine and doesn't require any upfront GraphQL experience. Take it from me. We also have some amazing open source tutorials for learning GraphQL if you're just getting started. Now, finally, we are going to have over 10 additional sponsors at the event exhibiting in not your run-of-the-mill expo hall, because these folks are doing some really cutting-edge stuff in web development, and they're going to have booths staffed by their senior engineers. So you can stop by and have some really great, hopefully thought-provoking, hopefully inspiring conversations with them. They might help you fix your problems or get past hurdles you've been struggling with. So generally, you'll want to check those booths out because they will make your life easier. They got some really cool products and services. So check them out. And yeah, we're really excited to be returning in person this May. But today, we have an amazing day of talks, very special, remote virtual talks. You can see the whole list of the upcoming talks in the schedule column to the right. And again, if you haven't already joined the Discord, you're going to want to do that. Come hang out with us. The link to that, again, is going to be in the footer at reactathon.com. Okay, so who's ready? You ready? I'm ready. We're going to kick things off here with 2 keynote presentations and then have some talks from the sponsors. So we're going to hear later from Mark Erickson, maintainer of Redux, who's going to tell us about the evolution of Redux async logic. But kicking things off first is our first keynote speaker, member of the Google Chrome team, who's going to be talking about how the Chrome Aurora team is advancing the web framework ecosystem, beginning with Next.js. So I am really excited to welcome, and please join me in welcoming to the virtual stage, Houssein Djirdeh.
Hi everybody, my name is Houssein Djirdeh and I'm a software engineer at Google. In this talk, I'll be covering how a small team of Google Chrome engineers are working with Next.js to help advance the web framework ecosystem. To kick things off, I'd like to introduce the name of our team and the initiative actively working on this. We're the Aurora team, and we're a collaboration between Chrome and open source tooling. Our primary mission is to ensure that developers have access to the right tools that allow them to deliver the best user experiences possible. Although we've worked with and funded different types of open source tools, our primary focus has been on JavaScript frameworks. But you may be wondering, why is Chrome working with open source frameworks like Next.js in the first place? Well, the goal of everyone in Chrome is to make the web a better place. And we do this by improving many APIs and core engines that power the browser, like V8. But we'd be missing a critical piece of the web if we also didn't try to improve the many open source dependencies that millions of developers rely on. We believe that better open source tooling results in a better web. React is one of the most popular front-end libraries that developers use around the world to build their UIs. So we would be remiss to not also include React in the list of tools that we work with. And lastly, we in the Aurora team believe that a framework that is opinionated in the right manner is the best way to provide a solid developer experience while also ensuring that end users get to enjoy great user experiences. Next.js does exactly that by bridging developer and user experience extremely well. Now, Next.js isn't the only opinionated framework that gives developers a good amount of control while also setting them up to build great web experiences. We're also actively working with a number of other well-established frameworks like Angular, Gatsby, and Nuxt. Our aim is to continue collaborating with these frameworks while also expanding our efforts to include some newer ones in the near future. If I wanted to showcase all the work that we've done and are planning to do with all the frameworks we're collaborating with, it'll take a lot longer than a single talk to cover. Also, the title of this talk is Next.js and Chrome, so let's talk about Next.js. When we started a working relationship with the Next.js team, we realized that the framework already did an excellent job of baking in many best practices, like server-side rendering, file-based routing, automatic code splitting, and even extensive CSS support, including tools like CSS modules and Style.jsx. In the years since, there have been an influx of even more amazing features that we in the Aurora team weren't involved with whatsoever, like incremental static generation, adoption of SWC, a Rust-based compiler, and internationalized routing, to name a few. One of the main avenues of focus for us, however, was user experience. How could frameworks be equipped enough to ensure that developers are always building applications that have great user experiences? Naturally, we align on improving the metrics that many Google tools use to assess user experience, the core vitals. We have largest contentful paint, which gives us an indicator of loading performance by measuring the time it takes for the largest element in the viewport to render. Then we have cumulative layout shift, which measures visual stability by calculating unexpected layout shifts on a page. And then there's first input delay, which measures interactivity by calculating the time it takes for the browser to respond after the user has made their very first interaction. And lastly, the Chrome metrics team are working on a new metric to better measure responsiveness on a page. And although this is still in development, we're working with the Next.js team to make sure that it can easily be used and measured in the framework as soon as it's finalized. For this talk specifically though, I'd like to go over how we on the Aurora team help build and ship a number of optimizations while diving into our rationale and design thinking. Zooming out, we wanted to find ways for developers to continue doing what they normally do, but bake in optimizations in a way that would not impede their development flow. On the contrary, we wanted to make sure our optimizations made your development experience even easier. Let's take images, for example. Most developers will have to work with images at some point in time during their development workflow. They may not think about it at first, but there's a lot of work required to make sure images are embedded and used correctly without affecting the experience of end users too significantly. But what if Next.js could completely take care of loading and displaying images in the best way possible so developers don't have to worry about it themselves? Now, we continue thinking in that same way for other typical scenarios that many developers have to experience, like third-party scripts. What if anytime you place a third-party script on a page, Next.js also handles loading it at the right time in accordance with all the other requests on the page? And the same for fonts. What if anytime you include a custom web font, Next.js does some magic behind the scenes to make sure that it gets fetched as soon as possible? And on to CSS. Wouldn't it be cool if the framework you use could identify the CSS that is immediately required for the first view and process that before anything else? We looked at different resources like images, scripts, fonts, and CSS and thought about ways we could simplify the workflow for developers while ensuring that all the right optimizations were in place to not negatively impact core vitals. But regardless of the fact that we've tried to meet developers where they are, we also know that developers in general will need some form of minimal guidance. Our work on conformance was to provide this to developers in the right place at the right time. Okay, we've seen the zoomed out picture, and I hope the previous slide summarized our thinking at a high level. But let's now dive into some of the details. We'll begin with images, and we'll start with the base case scenario. As a developer, let's say I want to include an image of a goat on my web page. If I'm thinking about how this may affect performance, I may be worried that it could increase paint times. Fortunately, this image is rendered below the device viewport, so I know it doesn't necessarily need to load immediately. For that reason, I go ahead and use the loading attribute to lazy load the image. Awesome. That was a pretty easy change. Now, the thing about loading content at a later point in time is that I need to be careful about it causing other things on a page, like text, to shift. Explicitly specifying the dimensions of the image can decrease the chances of this happening, so I add width and height attributes. Okay, great. Now I've got an optimization in place that can reduce the chance of paint times being affected while also not causing any serious layout shifting. The loading attribute for images, in and of itself, is supported in all major browsers. But for whatever reason, let's say that there are going to be some users that are using my website from an older browser that doesn't yet support the feature. Alright then, I'll include some code that checks for the attribute, and if it doesn't exist, I'll either write a custom polyfill or fetch a third-party library that can lazy load images. Great. Now I even have a backup plan to support older browsers. Thinking about my image a little more though, I realized I want to improve the user experience a bit, and instead of showing nothing while the image is loading, I'd like to add a blurry placeholder. I spent some time researching, trying to find a way to do this, and come across the blur hash library. I install it as a dependency, and then I write up some code that handles encoding the image to a blur hash. This took a little time, but I'm happy with the end result. However, I'm definitely starting to realize that there's a lot of work that's needed to improve image loading. Anyway, moving on, I noticed that although I've got some optimizations in place to defer when the image loads, I haven't done anything to make sure that the image isn't larger than it needs to be for some devices. So now is when I begin using the source set and sizes attributes to make sure the images are responsive or work well on devices of different screen sizes. After all that work to try and improve how my image loads, I realized that I can't get enough of goats and I need to put another image of a goat on my site. The difference with this one is that instead of being below the device fold, it's actually one of the first things a user would see when they load my web page. So instead of trying to delay when it loads, I need to try and load it as soon as possible. Luckily, there's a fetch priority attribute that works with images that allows us to provide a signal to the browser to fetch it as soon as possible. This is great, but at the moment it's only supported in Chrome versions 101 and later. I definitely want to make sure that users that use all major browsers get this benefit, so I consider using a different heuristic for this for the meantime. Link rel preload, which although has different underlying logic than fetch priority, similarly provides us a way to inform the browser that we want to load this resource as soon as possible. Whew, okay. I think we've added all the optimizations needed to improve how just 2 images load on my web page. But did you notice how much work we just had to do? We have to think about how to lazy load our first image while preloading the second. Using fetch priority as our priority hint was something that we also needed to think about, but realized is not yet fully supported by all major browsers. We also had to spend some valuable time trying to get blurry placeholders to work, while also thinking about responsive sizing. And again, layout shifting was something that we just had to consider very early on. Now this is a lot. And speaking from personal experience, the amount of work needed just to mitigate the impact to performance can sometimes make me feel like I want to scream. You can imagine how much extra effort this can take for the everyday developer who already has a million things in their mind and a long list of features and bugs they need to tackle. So we understood all of this when we designed and shipped a first-class image component in Next.js. First and foremost, we wanted to make sure that it had a bunch of optimizations in place without needing any developer input whatsoever, like lazy loading, on-demand resizing, and extensive loader support. And for when developer input is necessary, we wanted to make it as easy as possible while making sure that Next.js takes care of all of the heavy lifting. Want to add a blurry placeholder? Use a placeholder property with a value of blur, and that's it. Want to denote a particular image as high priority? Add the priority prop, and you're done. Next.js will even identify if you have an image that is responsible for being the largest contentful page element, and show a console warning if you're not using the priority attribute when you should. There are even more optional properties you can use, like one to control the layout behavior of an image. Layout fill, as an example, automatically sizes your image to that of its parent element, which is a pretty nifty thing to do with just a single prop. And lastly, we're always working on ways to better improve the developer experience of a component that does so much right out of the box. One way is giving the developer even more control with the option to use raw as the layout value. This essentially inserts the image with no predefined layout behavior, letting the developer fully control how it wraps and sizes on the page. However, this is still experimental and its design may change. Moving on to a different focus that we've also had since we've begun collaborating with frameworks, and that's trying to mitigate the impact of third-party scripts. A third-party script is an external script that a developer would add to their site for any particular reason. They're a great way to leverage already existing solutions to include specific functionality without having to write custom code for it. And many popular third-party tools are very powerful. The problem with third-party scripts is that it can be quite hard to figure out how much of an impact it makes to the performance of your site. There are so many different types of third parties that you can include, like cookie consent forms that may affect the largest contentful paint of your site, or add embeds that can cause layout shifting if you're not careful, or any heavy long-running dependency that can block the main thread and increase input delay. Just like with images, adding third-party scripts can bring a whole new set of concerns that need to be addressed. In a large application with many files and components, where exactly should one be placing third-party scripts? How can you tell when a script is render blocking, and if so, what do you do to prevent that from happening? Should one be using script async or defer? We knew that there was an opportunity for a component that takes care of a lot of these concerns and simplifies the process of using third-party scripts. We created a Next.js script component, and just like with the image component, its default behavior was designed to be as optimal as possible. Need to include a new third-party script? Just place it with the script component, and that will ensure that it only loads after the page becomes interactive. That way, you can be confident that it doesn't compete with critical page resources. But there can always be some instances where we need a particular third-party script to load as soon as possible. No worries, there's a strategy property we can use to make this happen, and we can specifically choose to load the script before the page becomes interactive. And what about scripts that are very low priority that we'd like to load as late as possible? Well, there's a lazy onload option that lets you do that by loading the script during browser idle time. We wanted to see if we could push the envelope even further and give developers the option to relocate and execute scripts entirely off the main thread in a web worker. Using Partytown under the hood, there's now a worker value that you can use to do exactly this. We recently shipped this feature behind an experimental flag, so it goes without saying, but please use it with caution if you want to give it a shot. And lastly, we're currently in the process of thinking of ways of building opinionated wrappers for many popular third-party libraries, so that developers wouldn't have to think about which loading strategy to use. Next.js could just load these as optimally as possible. This is still very early in development, but we're hopeful that it can be an additional feature that developers can find some use in. Let's change gears to fonts now. Very early on, when we spent quite a bit of time analyzing thousands of Next.js sites, it was quite apparent that many developers rely quite heavily on third-party font providers like Google Fonts. So we wanted to think of ways to improve how these types of fonts load in every Next.js application with absolutely zero overhead. The thing about font loading is that it can be quite tricky. And if we're not careful, other low-priority resources could easily interfere with the external font style sheet and files that we load. We added a feature to grab the content of a style sheet when a Google font is detected and inline it directly in the HTML. This eliminates the round trip the browser has to make to fetch font declarations, consequently improving paint times. By combining that with pre-connecting the font file and ensuring the font only gets inline during render time, this also has the benefit of minimally impacting build times as well as the time to first byte. This feature has already shipped and landed in Next.js, and it does this for both Google Fonts and Adobe Fonts. We've been thinking about possibly extending it to include other font providers in the future. Another feature that we worked on was automatically identifying and inlining critical CSS at serving time. The approach we took here was loosely based on the same technique Critters uses. Critters is a third-party library that anyone can use to incorporate this on their site. But we wanted to have that behavior baked into Next.js without the additional overhead of plugging in an entirely different library. It's worth noting that this feature is also still experimental, but we're evaluating ways to either land it at stable or make adjustments if necessary. The last thing I want to cover for this talk was our thinking on conformance. Conformance is a term that we use internally at Google to ensure that our own frameworks have the right defaults in place, but also includes actionable guidance so that developers don't run into common problems that are easily preventable. In Next.js, we created a new ESLint config and plugin along with an integrated experience out of the box that makes it easier to catch problems directly in the IDE or in your terminal. Very recently, we've even expanded our horizons of including guidance to other popular tools that many developers rely on. One example is Lighthouse, which will now detect if your site uses Next.js and display framework-specific suggestions in addition to the core messages that are already provided. And that's everything I had for this talk. I hope this was useful, and although we covered many things, there's still a lot of detail and nuance that I didn't get the chance to dive into. So here's a summary table that lists many of the things that I just covered with some links in case you'd like to learn more. I'll make sure to share this and the rest of the slides on Discord and Twitter. Thanks for tuning in, and I hope you enjoy the rest of the talks in Reactathon.
Hi everyone, welcome to this talk. My name is Djirdeh. I've been a long-time user of AWS, and since 2018, I've also been one of the AWS service heroes as well. So nowadays, I spend half my time working with Lumigo as a developer advocate, and Lumigo, of course, is one of the sponsors for this event, but it's also one of the best tools out there for troubleshooting serverless applications. The other half of my time I spend working as an independent consultant, where I help other companies adopt serverless through a combination of training, advisory, and sometimes working with the client to deliver their product. And in my capacity as a consultant, I've worked on a couple of production projects with AppSync in the last 18 months. And those projects span across several different industries, including a social network, a healthcare app, and a document assembly app as well. All of these projects have some B2B component and also some multi-tenancy requirements, and all three of these projects were fairly large, as you can see from the number of resolvers in those AppSync APIs. And the stack for these projects pretty much consists of AppSync, Lambda, and DynamoDB, and I've used Cognito and Auth0 for authentication. And for search, Algolia is my preferred choice, but for some of these applications, because of requirements like HEPA, we settle for Amazon Elasticsearch instead. And for all three of these projects, I use Lumigo to help me debug and troubleshoot the app. And here are some of the lessons I've learned in the time I've been working with AppSync. The first and arguably the most important lesson is that you should use the Lambda resolvers as a last resort. Because AppSync lets you write resolvers that reads and writes data from and to DynamoDB using VTL templates, where you say what operation you want to do and the parameters you want to use. Now, VTL is not the most easy to use programming language, but honestly, you don't have to write a lot of VTL code. Most of the time, you're just writing some JSON object that describes the DynamoDB operation that you want to do. Of course, sometimes you do still need to stick a Lambda function in there so that you can implement more complex business logic or call some third-party services using the SDK libraries. Or maybe you want to leverage the built-in retries and with exponential backoff that you get from those SDKs, or the Amazon SDK gives you that as well so that you can get better resilience. Or maybe you want to implement some kind of a circuit breakers pattern or fallback pattern so that in case there are problems with DynamoDB service itself, your system can still continue to operate. Or maybe you just need to do more than one thing, like getting an item from DynamoDB and then doing some update against that and then saving the changes back to the table, which you can also do with AppSync's pipeline resolvers, but often find that it's easier to write those logic in the Lambda function instead. Of course, adding a Lambda function to the mix also is going to add another source of latency to your resolver, especially when you consider the fact that you're going to see cold starts sometimes, even if the traffic in production keeps the functions warm so that it's not nearly as bad as you may think. But when you have nested resolvers, those Lambda cold starts can really stack up, and that's when things get a bit ugly. And it's also another thing that you have to pay for both the Lambda invocations as well as the amount of time that your function runs for. And you have to worry about the regional concurrent executions limit with Lambda, because that limit applies to all the functions running the region, including functions that are not part of your AppSync API. So for simple CRUD operations, you shouldn't be using Lambda resolvers at all. And instead, you should go straight to DynamoDB from AppSync using VTL templates, because it's going to be cheaper, it's going to be faster, more scalable. And I think it's also simpler when I don't have to write and configure another Lambda function and all the things that come with that, including setting up IAM roles and so on and so forth. But quite a few people have told me that they don't like this approach because they end up writing a lot of custom VTL code, and VTL is not their favorite cup of tea. Now, this stumped me a little because it's kind of the opposite of the experience that I've had. And it turns out almost everyone who complains about the amount of VTL code they have to write were using single table designs with DynamoDB, which brings me to my second point, and that you really don't need to use single table designs. In fact, when it comes to AppSync, it's preferred not to use it, and allow me to explain. In case you haven't heard about single table design, it's basically a collection of practices and modeling techniques that solves the problem of data joining when you're using DynamoDB by pre-joining the data into collections into a single table. Now imagine if you had the users table and an orders table, and to build some kind of a UI page that shows the user profile alongside the user's order, you will have to make a GET request to the users table to get the user profile, and then you have to make another query request to the orders table to get the orders that belong to this user. Now that's two separate DynamoDB requests, whereas if you put both users and orders into one table, and they can use some clever schema to squeeze both user IDs and order IDs into these opaque primary and sort keys, then you can use one DynamoDB query to get both the user and his orders by looking for the primary key user number 1, where the sort key is either the literal user or it starts with order number, and you get both the user and the orders in one request. And then you will have to split the data out in your code, which, if you think about it, is kind of clever, right? And there are lots of other patterns that can help you model one-to-many or many-to-many relationships inside a single table. But the fact that it's clever also means that there's going to be a bit of a learning curve to it, especially for people who are new to DynamoDB, and it's generally speaking not great for greenfield projects as well, because once you've modeled all of your access patterns into your schema, it's not going to be easy to change those access patterns later on, and it can be difficult to add new patterns later as well. And when you have one table for each entity, you can also use the cost tags to track the cost for each table and monitor the usage cost by entity. You can't do that with single table design because all the data access is going to one table. And the funny thing is, the issue of data joining is basically a non-issue when it comes to GraphQL and AppSync, because the user and orders can be handled by two separate resolvers. Each is going to fetch data from a different DynamoDB table, and AppSync is going to join the data together for you for the response, so you don't actually have to do all that joining yourself. That being said, I do think you should learn about single table design and understand the modeling techniques so that you can use them where they actually make sense. Just don't go around making a religion out of this whole single table design thing and literally put all of your data into a single table, because that's just going to make your life more difficult than it really needs to be. And when you use the single table designs with AppSync, you're going to find that you do end up having to write a lot more custom BTL code in order to construct those custom primary keys and sort keys, and having to split the data in the response template and so on. But advocates for single table design might say that, but what about all the cost savings? Fetching multiple entities in one query is going to be cheaper than multiple get item requests, which is true. But those cost savings are only going to amount to anything even worth thinking about when you're running at massive scale. For Amazon, it absolutely makes sense. But for most of the applications out there, the cost of engineering time is going to far outweigh the DynamoDB cost savings that you're going to make by using single table designs by orders of magnitude. And when it comes to cost saving, if you're really concerned about that, then caching is a much better strategy to save on your DynamoDB costs. For one of the projects I mentioned, we achieved an average 99% cache hit rate. And that kept our DynamoDB cost to just a few dollars after we launched the app and pretty much ramped up to about 25,000 monthly active users straight away. And another side effect of caching is that it's going to make your API faster as well. Our 99th percentile latency was consistently below 200 milliseconds, and the client was very happy about that. And speaking about caching, AppSync supports caching out of the box, and you can choose between having full request caching or per resolver caching, and I think you should pretty much always go with the per resolver caching solution. If you take this GraphQL query to fetch your timeline from a Twitter clone as the example, with full request caching, AppSync is going to cache the response against this entire request, and it's going to use the context arguments and context identity as the cache key. And this is not going to get you very far, because a user profile can appear in many tweets and show up in many users' timelines. And even though the user profile probably doesn't change all that often, we're still going to have to fetch the same data from a database many times, one for every caller. And similarly, the tweet is going to show up in many people's timelines, but each user is going to have to fetch the data from the database, which, if you think about it, is just very inefficient. With per resolver caching, we can enable caching for individual resolvers and choose what gets included in the cache key and the time to live value as well. So we can choose to use the profile ID as a cache key. So after the first user fetches a profile, all the other users is going to get the profile from the cache until the TTL expires, which is far more efficient from a caching perspective. In general, you want to cache data that doesn't change often and then cache them for everyone. And doing this is going to be an important part of a good caching strategy that's going to give you a very high cache hit ratio. But one thing to keep in mind is that even though it's possible to flush the AppSync cache, if you want to clear the entire cache, then there's a control plane API you can call, but to flush individual items, you have to do it via VTL resolver. The use case for this is if you want to delete a previously cached response during a mutation. But if you need to delete cached items from, say, a background process, then you have to add the mutation to your GraphQL schema and make sure that that mutation is only accessible by this background process. For example, by using AWS IAM as the authorization method for the mutation. And when you have caching enabled, every virtual machine in the AppSync fleet for your API is going to maintain a persistent connection to the underlying Redux node. And creating this connection has a latency overhead, which you're going to see from time to time. And in my experience, this can add up to 2 seconds to the request latency. If you have X-ray enabled, then you can see this in the X-ray trace. Unfortunately though, this time is not labeled in X-ray. So it's basically this big gap that you see in your trace where it looks like nothing's happening. But under the hood, this is the time the AppSync is using to create a connection pool to the underlying Redux node. Okay, so lesson number 4 is that you don't want to leave the field resolver log level setting on all in production because it's going to get really expensive really quickly. If you go to the logging session in your AppSync settings page, you're going to see the field resolver log level, and you can set that to between none, error, and all. And the problem is that these choices are basically having close to nothing and having logging down to 11. And when you set the log level to all, it's going to give you so much logs, including the input and output for every resolver and how much time the resolver took, which is great for debugging, by the way. But it's also going to get really expensive really quickly because all these logs are going to CloudWatch logs and it's charged at the 50 cents per gigabyte for ingestion. And if you keep them around, then that's going to be 3 cents per gigabyte per month for storage after that as well. So you definitely don't want to leave the field resolver log level to at all when you go to production because the cost of those logs in CloudWatch can be prohibitive. But if you're like me and you want to have the cake and eat it too, then check out this blog post which explains a workaround I found where I use a pair of cron jobs to basically change the resolver log level between error and all. So I get about 3 minutes worth of detailed logs every hour, which is not a great workaround, but it's the best I can think of without some kind of official platform support from AppSync. And on to lesson number 5, which is you need to have a way to handle users' errors gracefully if you don't want them to trip your Lambda alerts constantly. When it comes to HTTP, you have 400 status codes to represent user errors, and then you've got the 500 status code to represent the system errors. And if our system is not working, we want to be alerted straight away so we can fix it. On the other hand, if users are making mistakes and sending bad data, then it's something that we want to keep an eye on because maybe our UX is not good and is making users do silly things, but it's not something that we need to deal with urgently. And we definitely don't want to be woken up in the middle of the night because of them. When you're building REST APIs with API Gateway and Lambda, you can do your validation and then return a 400 error as response. So the Lambda invocation was successful, but it lets us tell API Gateway to respond to the caller with a 400 error. With AppSync, however, there's no way for us to tell AppSync to return a 400 error from the Lambda resolver. So if we detect some user error, all we can do is to throw an error, which AppSync is going to capture and include in the error in the response. The problem is that this also is going to fail the Lambda invocation, and that's going to trigger any alerts we have on the Lambda invocation errors. And we should, so that we can be alerted when our function actually fails. What you can do instead is to return a payload that captures the error information where applicable, and then use a custom VTL response template to check if the Lambda response included an error object, And if so, throw an error here in the VTL response template instead. This way, the Lambda invocation is still successful, but we're able to fail the resolver with an error. Lesson number 6 is when you're modeling multi-tenancy with Cognito, and this seems to be quite a common requirement with a lot of applications. If you're building any sort of B2B application, this is likely to be relevant to you, where you need to model having tenants and users belong to a tenant, and each user has one or more roles, which limits them to some subset of the actions that your API supports. The simplest way to model this with Cognito user pool is to use user groups to model the roles and then capture the tenant ID as a custom attribute. And then in your GraphQL schema, you can limit access to specific actions to some subset of the roles by adding this decorator to the GraphQL operation, and you're done. AppSync is going to handle the rest. In this case, only users that belong to either the admin or super user group is able to call this add user mutation. And to stop users from being able to access other tenants' data, you should never accept tenant ID as an argument in your GraphQL operations. And instead, always take the tenant ID from the context.identity object, which is the identity of the user that has been resolved and verified by Cognito. And so as a summary, here are the 6 lessons that we've covered today, that you should prefer using VTL over Lambda functions, and that you really don't need to use a single table designs with DynamoDB when you're working with AppSync. And in terms of caching, always use the per resolver caching, and in terms of logging, you don't want to leave the field resolver log level to all when you go to production. And you also need to have a way to handle user errors gracefully. Otherwise, you're going to get a lot of alerts from your Lambda functions where they're just user errors. And lastly, if you want to model some kind of a SaaS application with multi-tenancy requirement, then you can use Cognito user groups and the custom attributes to model that with Cognito and AppSync. And that brings me to the end of this talk. Thank you guys very much for being with us. And as I mentioned before, I spend most of my time as an independent consultant. So if you want to see how serverless can help you go faster, or you need some help to upskill your team, then go to theburningmonk.com to check out what I do and how we can work together. And I also got a new video course on AppSync, so check it out at the appsyncmasterclass.com. Once again, thank you very much, and I hope you enjoy the rest of the conference.
Hi, I'm Mark Erickson, and today I'd like to talk to you about the evolution of Redux async logic and side effects. A couple quick things about myself. I'm currently a senior front-end engineer at Replay, where we're building a true time-traveling debugger for JavaScript. If you haven't had a chance to see it, please check it out. I'm known for a lot of things, like answering questions in basically every text box that exists anywhere on the internet, collecting links to useful resources, especially React and Redux related, writing extremely long blog posts, and I am a Redux maintainer. I've worked on Redux Toolkit, React Redux, Reselect, and a lot of our docs. But I'm also known as that guy with the Simpsons avatar, and I pop up pretty much everywhere. So let's start by talking about Redux middleware. Middleware are a kind of add-on for the Redux store that allow us to customize the behavior of the store's dispatch method. Middleware provide a third-party extension point between the time that you dispatch an action and the time that it reaches the producers. And this helps us solve a couple different use cases. One is centralizing logic that belongs to the entire application, like logging or crash reporting. And another is giving us a way to plug in asynchronous behavior and logic with your choice of syntax and behavior. Now, why did middleware exist in the first place? There's a couple really good quotes from Dan Abramov and Andrew Clark way back when they first created Redux. And Andrew points out that the reason the middleware API exists is because they didn't want to force users to follow a specific pattern for async logic. Instead, they wanted to enable the community to build their own solutions and plug them into a Redux store. Similarly, Dan pointed out that even though RxJS was popular at the time, they didn't want to force users to have to learn the complicated RxJS API. So middleware were designed to be more flexible and simpler. Overall, middleware form a pipeline around the store's dispatch method. And middleware can pass through basic actions. They can also look for non-action values and transform them into some kind of plain action object in some way. So any middleware can inspect actions, log them, modify them, delay them, dispatch other actions in response. And this also makes them a good place to put things like a persistent server connection, like a WebSocket. Middleware are written using a functional programming approach where we have 3 nested functions. And the functions in turn accept a store API object with dispatch and get state, a function reference to the next middleware in the pipeline, which could actually be the original store dispatch method, and another function that accepts the current action that is being passed through and does something to process it. A typical example of this might be a logging middleware, where we can log whatever's being passed through and run some code before the action is processed by the reducers, pass the action to the next middleware in the pipeline. Eventually it reaches the reducers, is processed, the stack unwinds, and now we can call get state to log the state after the action was processed. Now there's hundreds of different middleware that are out there, but there's a few that have become very commonly used, and especially for things like writing async logic. And the most commonly used middleware is the Redux Thunk middleware. This allows you to pass a function into the store's dispatch method. And we can see here that the actual implementation of the Thunk middleware is really very small. It looks at the current action, and if that action is actually a function, it's going to call it, pass in dispatch and get state as arguments, and return whatever that Thunk function returned. This gives us the ability to write some fairly complex synchronous logic that needs access to the store, or moderately complex async logic. Now, all tools have trade-offs, and for the Thunk middleware, the benefits are that you can write this logic with just some basic functions, and those functions may contain any logic, sync or async. But there are some downsides. You can't respond to other dispatched actions. It's very imperative code, and you can't cancel a Thunk. It's just a function that's running start to end. There is a fairly common pattern that you would usually see in a Thunk that is making some kind of an AJAX request. Typically, we would dispatch one action before we make the request, and you would use this to, say, update some loading state and show a spinner in the UI. You make the async request, and then you dispatch some kind of a success or failure action after the response has come back. The next most popular middleware is Sagas, and Sagas use ES 2015 generator functions, and the Saga middleware provides a set of special effect APIs. And these effect APIs return descriptions, kind of like Redux action objects, saying here's what we want the side effect to be, such as call this function with these parameters. The generator functions are executed by the Saga middleware, and whenever it sees one of these effect descriptions, the middleware executes the effect and then resumes the pause generator, possibly passing in a value like the response from the server. The Saga middleware has some very powerful effects, like the ability to fork off background threads, or debounce, or delay, or wait for specific actions. And this gives Sagas the ability to do very complex async workflows. Some people like Sagas because they're more testable in a way. The Saga isn't actually executing an AJAX request itself, so you could test a Saga and verify that it's returning the effect descriptions that you want. Some of the downsides are that generator functions are complex. There's a lot of stuff to wrap your head around, And especially when you combine that with the very specific Saga effect APIs that are unique to Sagas and don't exist in other libraries. Next, we have observables, and the Redux observable middleware solves the same kind of use cases as Sagas, but it uses RxJS pipelines called epics to do that kind of work. And so epics are RxJS observables that have been chained together to listen for actions and form some kind of processing pipeline. So you could write an epic that makes requests when it sees a specific action, or does a whole bunch of debouncing and throttling and merging of data together. One of the advantages here is that RxJS is its own library. It's not specific to Redux. And so you could use a lot of that same knowledge with other frameworks like Angular as well. The downside is that RxJS has a very complex API. It can be kind of hard to debug these pipelines because you can't easily pause in the middle of it. And it does add a fair amount to the bundle size. Now, we have our official Redux Toolkit package, which is the standard way to write Redux code today. And RTK builds in support for thunks in a couple of different ways. One is that the Configure Store API automatically adds the thunk middleware by default. You don't have to do any extra work to do that. We also have a Create Async Thunk API, which abstracts that standard pattern for dispatching actions before and after an async request. You can still use sagas or observables with Redux Toolkit if you want to, but because thunks are so widely used, we felt it was best to give RTK support for those by default. Now, along with that, we have specifically recommended thunks as the default approach for several years now. The most common async logic you want to do in a Redux app is just making a basic AJAX request. And really, sagas and observables are overkill for that. It's kind of like using a sledgehammer just to drive in a basic nail. Sagas are powerful, but they're really too powerful. And generators and the Saga API are something you have to spend time learning to actually use effectively. You also have to write some extra boilerplate with sagas, like adding extra watcher sagas to listen for specific actions, and then kick off another saga that does the actual work. And sagas don't really work that well with TypeScript either. RxJS is very powerful, but it has a lot of complex operators that can be kind of hard to learn. And it's not as widely used in the React ecosystem either. Now, today, within the last couple of years, we've really changed some of the things that are built into RTK Query to support the kinds of things that we see people wanting to do with Redux. Because data fetching is so common, last year we released a new RTK Query API built into Redux Toolkit. And RTK Query is a purpose-built data fetching and caching solution that takes inspiration from libraries like Apollo and React Query. And it completely abstracts the entire data fetching and caching process. You define a set of API endpoints that tell RTK Query, here's where we fetch the data, and here's how I generate things like query parameters. And it takes care of all the work of actually fetching the data, managing loading state, and caching the results for you. And because it's built on top of Redux Toolkit, it's actually UI agnostic and can be used with any UI framework, not just React. But it also comes with built-in React hook support. Every endpoint generates a React hook that you can use in your components right away, whether it be making a query or triggering a mutation to update the server. And so RTK Query can actually replace the need to write any logic to actually fetch data and update it from the server. RTK Query is designed to have a single API slice per server with many endpoints inside for things like getting a list of posts, getting one post, updating a post, user auth, and so on. It's a document-style caching system, so every response is stored separately. Trying to combine and merge different responses together is a difficult problem that we don't want to try and solve ourselves right now. It also has some unique features like a cache query lifecycle that allow you to do things like fetching data from the server with an initial request, opening up a WebSocket to receive update messages, and then applying updates to the cache data on the client as we receive those from the server. We also recently introduced a new listener side effects middleware in Redux Toolkit 1.8, and this fills a gap in RTK's existing capabilities. Thunks can't be used to listen and respond to dispatched actions. They're just functions. So the listener middleware gives us the ability to run code in response to dispatched actions. So it solves a lot of the same use cases that you previously would have had to use sagas or observables for. You can think of this as kind of being like React's useEffect hook, but for Redux store updates instead. And it comes with a set of API primitives built in that allow you to replicate a lot of the same patterns that you would have seen in sagas or observables. So the good news is this is built into Redux Toolkit. It lets you use very familiar async await syntax in your logic, very similar to Thunks in a lot of ways, and it works great with TypeScript out of the box. Now, this is a fairly new API, so I wouldn't call it battle tested yet, but we do think that this can solve most of the same things that sagas and observables would have done. So listeners can match against individual actions, groups of actions, or even state changes in contents instead of actions. And the listener API gives each effect method a set of primitives it can use to execute long-running async workflows. Things like waiting for a specific condition to become true, whether it be a specific action was dispatched or the state now contains a certain value. And promise-based APIs are normally very hard, almost impossible to do cancellation with. Generators are great for cancellation behavior because generators can be paused and resumed by the calling code. Well, even though listeners use a promise-based API, we've built in cancellation support. So you can do things like canceling all existing instances of a listener, or even kicking off a sort of child thread, letting it do some long-running work, waiting for a stop action to be dispatched, and then canceling that long-running behavior. This gives you some very, very powerful capabilities, and we feel that the listener middleware can really do probably like 80+% of what sagas and observables could, but with a smaller bundle size and a simpler API. So, what are our recommendations today? And that really depends on what problem you're trying to solve in your app. If you're trying to do data fetching, we would say start with Redux Toolkit Query. Use that as the default approach for data fetching. If by chance that doesn't solve the needs that you have in your app, fall back to either create async thunk or handwritten thunks if you really need them. We would specifically advise against trying to use sagas or observables for data fetching scenarios. It's really overkill. If you need to react to dispatched actions or changes in the state, start by using the new RTK listener middleware. If by chance the listener middleware can't do all the things that you needed to, then look at sagas or observables. And finally, if you need to run some complex logic that has access to dispatch and get state, look at thunks. And we have some good examples of this in the Replay app that I work on. The Replay app interacts with a backend debugger definition that needs to do things like requesting object previews or triggering pauses or dispatching multiple actions. And so this code base is full of thunks. And they're not your typical async thunk. There's no loading, state, start, success, failure behavior. But thunks are a good place for us to put that kind of logic. So hopefully this gives you a good idea of what some of the options are for async logic in Redux and how our recommendations for using Redux have changed over the years. Hopefully these APIs in Redux Toolkit make it easier for you to write your apps, and we'd love to hear how you're using them today. If you have questions or would like to chat more, please drop by the Redux channel in the Reactathon Discord, and hopefully this information has been helpful. Thanks, and take care.